What's going on, everyone? Welcome back to my channel. In today's video, we are going to be building a Python project. This is the second Python project in this series that we're building. This project is a number guessing game. This is a beginner level project. We're going to be using object-oriented programming, and if you follow along with this, then it should just give you a good idea of how you can structure projects that you're building on your own. Let's jump over onto my computer and I will show you how the final product of this project works. Okay, so I went ahead and I wrote all the code for this project and I got it working. It's about 150 lines of code, and I can give you an idea of the basic functionality of this number guessing game. All right, so let's run this program and I'll show you how it works. So down here, after running it, we're gonna get this prompt down here in the terminal. And it says to guess a number between 0 and 100 or type H for a hint. So if we try, let's just try a random number, 75. It says that number was incorrect and it decremented our score by 1. So now let's try 25. It says that guess was also incorrect. So this could take a while. It could take up to 100 guesses. Let's try a hint. We'll type H to use the hints. We can use either bisection or warm cold. These are hints that I built into the program, so we don't really know what these do. Let's try typing help, see what it says. And it says bisection, divide the range in half, costs up to half the range. Warm cold, warm if the last guess is plus or minus 15% of the answer, cold otherwise, and the cost is 20. Let's try warm cold. And it says that our answer was cold. All right, so let's go back to like somewhere around, let's try 50. And we can do H, warm, cold. And that answer is also cold. So yeah, this run was not a good run for me. I did not do very well in this particular game. My score is 9 right now, so yeah, it's not going to do very well. The highest score that I've gotten is like in the 30s, but yeah, this is the game. This is how it works, and I can show you another example with the bisection search. So if we do H bisection, it's expensive, but we can see that the correct answer is less than 50, but it costs 50 points to do that. But what we really want to do is we want to build this thing. So let's try building it from scratch and you'll have a better understanding of how this works, and you can try modifying it. You can build other hints. You can change the way that the hints work. And I'll show you the patterns that are used within this game. So we're going to start completely from scratch. All right, so on GitHub, I have a Python projects repo, and now I'm adding to this repo, I'm adding this number guessing game. And we're creating as a Python package, which just means it has an underscore init underscore .py file in it. There's no real reason, I guess, why I'm setting it up this way. It's just in PyCharm. If you click new, you can go to Python package, and that's just how I created each one of these. So for the number guessing game, the way that we're going to do this is we are going to build our code into 3 different files. Okay, so the main parts of this are going to be the main. The main file is going to be where we like kick off our game. Then we also want a file for the game. We're going to have an object or a class / object in our Python program that is going to represent the game and all of the details of the game. And the other file that we're going to need is a file to store our hints. Okay, and the hints sort of form an interesting pattern within our program, and I came up with this pattern deliberately. So I actually tried to film building this project from scratch just in one go, but I found that it kind of degrades the quality a little bit because I have to like stop and think about how I'm actually gonna build it and architect it. So I decided to actually just build it out and then recode it from scratch, which is what we're doing now. And yeah, so I came up with this structure and this architecture from going through the exercise of just building it out. And I'm going to try to explain all of my thought processes as much as possible, so that way you can kind of learn like how to build projects, how to approach building projects. So as I mentioned, the way that I'm thinking about this main.py is for actually launching the code. So this is like the game. So this is a common pattern. You have this if name equals main, and I guess like this makes your Python script like executable in a way. Like you can run your file, and when you run your file, it will run whatever code is down here. So down here, we will call into the function start game, which we haven't created yet, but up here we're going to create the function for actually starting the game. So the way that we can think about this main file is that this is where we're going to be pulling in all of the components of our program, of our application, and this is kind of like the script. This is where we're like launching things, where we're kicking things off. So we'll put all the logic in here, and up here we should have imports for at least like the major parts of the game, for the code that we're gonna need to like launch the program. So I like to go through and just build out like the structure of the program that I'm building, and I like to make sure that everything is running all the time. So I like to just kind of run this, make sure, yes, we are running, we are operational. There's nothing happening, but at least there are no errors. So in here, now we want to create a class, and this is going to be, I'll zoom in so we have a better view here. We're in the game file, and we want a class called number guessing game. All right, and we're gonna need an init method down here. Not really sure what we're gonna need to pass into this yet, but this is what we are going to need for our basic game. Now let's go back into our main, and to start the game, we're gonna need the game. So we'll say from game, or I guess we have to do number guessing game dot game import number guessing game. And down here we can say game equals number guessing game, and let's just make sure that this is running now. We're good. Okay, so our environment and everything is working well. We have like the basic structure of our program here, and this is a good thing. So within our number guessing game, I want to come up with a function for or a method for running the game. All right. So this because even though we're starting the game within this function here, but the running of the game, this is where the core logic for like keeping the game running is going to exist. Okay, so there will probably be like a while loop in here. We'll have a while loop, and we'll just keep going through the while loop until the correct guess has been guessed, or it gets to 0, right? Because if it's at 0, then we probably want to end the game that way too. So our start game will also have game.run, and it looks like that should be just about it for the number. Oh, we probably need to pass in some parameters in here as well, and we could parameterize the number guessing game much more. Maybe we could have like the user give arguments to our program and pass them into the game. Like they could choose the number range and things like that. I didn't really get that sophisticated, but this is our basic program for the main file. Let's go back over to game.py, and in here, we need to think about the parameters of our number guessing game. The only parameter that I really want right now is the number range. Okay, this is like the range of the guessing that we are going to be doing. In the example that I showed you, it was 0 to 100, and I actually want to just hard code that in. So I mean, kind of hard code it. We'll set it as a default argument for this parameter, and we will pass in this number range as a tuple. So these are like decisions that we need to make about our program. This is how our program is going to be running. And you might ask like, well, how did you come up with that? How did you think about that? I just made the decision. I just said, this is how we're going to represent our number ranges. Okay. So now in here, we need some attributes for our object. Once we create this object using this class, we need some way of storing the arguments that are passed in. So here we want num range, and this is going to equal the num range that we are passing in. And then we also need the points, which are going to start out as the self dot. Actually, you know what I did? I just decided to hard code this. So I just said points are going to be 100 and self dot max points is also going to be 100. And again, we might be able to like parameterize this or have some way of logically determining this based on the number range, but for now I just wanted to hard code this. Okay, so the idea here is that the points will change and the max points will not change, but at least we have some way of knowing like what the maximum number of points were if one of our hints needs to use that number to determine how much something should cost. So I'm storing the max points as well. All right, and now let's also keep track of the guesses. These are the guesses that we've made, and we also want to keep track of the previous guess. And these are things that, again, the hints might want to use. And finally, we also have our self.answer, and this is going to be randomly determined. So we're going to need to import from the Python built-in library random. So random.randint, and this takes two values, A and B. This is a range. Well, we have our number range as a tuple, so let's use this star operator and we'll call self.numRange. And so the first value will be A and the second value will be B. And that's how we'll get our answer. Now, if somebody were, if somebody obviously wanted to cheat in this game, they easily could, because you could just go into the Python code and print out the answer. But we are going to treat this like we have fair users who actually want to play the game for their own enjoyment. So fine, we'll store the answer within our object, and it's fine. Okay, so these are the attributes that we are going to need in our code. And again, like, I didn't really know that I needed all these things to start out. Like guesses, I wasn't really planning on storing that, but as I was developing the hints, I realized that, okay, that could be useful. So I evolved this over time a little bit, and but this is what I came up with. These are the things that I decided that would be useful. So now for running the game, we can go down to that code. Well, let's just make sure our program's working. So let's go back to main. If we run this now, it's still working. Okay, that's good. And now we can start to build out the run function. So we'll do while true, and then we'll have some way of like breaking out of it when the game has been completed. All right, so rather than typing out the entire print statement that I was using, I'm just gonna copy and paste it in here from the program that I had already written. Oh yeah, and it's an input. So the way that this program is going to work is with this built-in Python function input. And the way that this input function works is it's going to print out whatever prompt you pass into it, and then it's just going to wait until the user gives some value to the program. So I can just walk through this really quick. It says to guess a number between, and then it's going to do like format this a little bit better. So it's a self.numRange the first one, and then self.numRange the second value. And then it says or type H to use a hint, and I put a space here at the end, so that way when the user types, it's not like right on the words that are being printed or that are being typed in. So let's just try this, and I'll show you. Let's see, make sure that this is working. So let's print out the user input that is passed in. Let's run our program. Guess a number between 0 and 100 or type H. So let's try 88, and then it just prints out 88, and then it runs the same thing again. But obviously none of the game logic is actually working at this point, but that is working. And if you don't know how this F statement works, it's a way of formatting text in Python. So let's pull up an interpreter down here, zoom in a little bit, the way that you can work with strings in Python is you can say like hello and then do this curly brace thing. Then you can do a dot format. Okay, this is a method, a method for strings. And then you can pass in some value into here, like you could say Tim. Okay, now if I press enter, then it's going to format this string. It will take the value that you passed into the format and place it into the curly braces. And if you have multiple curly braces, then you need to pass in the same number of values for the number of curly braces that you have. You can also do keywords. So you can do name in this curly braces, and now it's going to look. You need to also use the keyword in the format function or method. So let's call this, and it works the same way. So a simplified version of this is to do what I did with these F strings, they're called. So now it works the same way, right? Like, but you need to pass in the variable into these curly braces. Here in this program, in this interpreter down here, name has not been defined, so this is going to throw an error. But if we were to define name as Tim as a string, now we can run this again, and boom, it's working. So that's how F strings work, and that's how we're using it here. We're doing an F string, and we're passing in the variables. You can pass in integers. You can pass in anything into this. Python, as a high-level language, knows how to manipulate different data types into the proper data type. So here we're just passing in the first value of the number range and the second value of the number range, or we're going to allow the user to type in H. All right, so let's add some logic down here. So what we need is if user input is equal to H, then we need to do something. And we'll also say whatever we end up doing, we want to make sure that we continue after that, okay? Because that's important for this next step. Because if this is a hint, then we're going to want to do the hint-based logic. Like we're going to want to do all the things related to if the user is looking for a hint. But what I don't want to do is I don't want to then, like, for all other cases, I don't want to say like else and then have to write all my code down in an indented block. So instead, I'm just going to continue after this hint logic. And now, what if there's something else? So if there's any other value there, what I want to do is I want to try to turn the user input into an integer, okay? And we're gonna call that the guess. So we'll try to turn this into an int. So we'll say int user input. And if this doesn't work, then that means whatever they passed in is not valid, right? So we need to say something like print, or no, sorry, we're not saying print. We are printing error. This or your input was not a valid guess. Okay, and now we also want to continue. All right, so that is our basic logic for checking what the user input is, right? And now let's come down here and we will print out the guess. And if we're in here, we will just print out hint. All right, so let's rerun our program, just make sure everything is working properly. So they can type H to use a hint, and it says hint. Or they can type a guess, and then it prints the guess. All right, so we're in business here. All right, so there's one other thing that I wanted to add to this in this try block, and that is that if the guess is less than self.numRange1, or sorry, 0, or guess is greater than self.numRange1, then we're going to want to raise an exception. If they're guessing a number that is out of range, then we don't want to count that in our game, and we just want to say like, hey, that wasn't valid, you know? So if we raise the exception in this try block, then we go into the except, we'll print this out, and we'll handle it in the same exact way. So that's how we'll handle the cases where they're guessing out of range. All right, so now we have our basic logic for running our game here. This is essentially how this program is going to work. I've realized that there are a couple more things that we're going to need to add as attributes in here. I'll get to that a little bit later though, when it's relevant. Let's talk about two other methods that we are going to need to develop. We are going to need a method called apply guess. Okay, and this will be the way that we will handle the guesses. And then we also want the way of handling the user hint. So apply user hint, or I guess I called it get user hint. Get user hint. All right, these will be the two methods for handling both of these two cases. That way we don't need to just shove a bunch of code into this if block and into this try block. We'll have two separate methods for handling these cases. So in the apply guess situation, we want to call self.apply guess, and we're going to pass in our guess into here. And then from within here, we can just print out the guess. And let's just make sure our code is running. Okay, 88. Boom, it's working. Okay. And for the get user hint, the way that this is going to work is if there's a hint, we'll just call this method. So self.get user hint. And in here, we'll have like another while loop for managing the getting the hint. So we'll do this one first. We'll say while true. And again, I'm just going to copy and paste my my input statement, because again, we're going to need to, after the user types H, they need to they need to say the name of the hint that they want. So let's take a look at this. We have self.hints.keys. The problem is that we haven't developed our hints yet, so we'll get to that. And I was kind of mentioning something about this before, but I'll just say that this is how our system is going to work. There's going to be a prompt for getting the name of the hint that needs to be used. And then the user will give the name of the hint, and then we'll do the logic for using that hint. All right, so we need to develop our hint system. So here's the way that our hint system is going to work. This is a pattern that we are going to use. All right, we are going to say within our number guessing game, we can add hints to this dictionary. All right, and the way that this dictionary works is that the key will be the name of the hint. So if you remember in our in the game that I showed you, we had the bisection hint, and we can just put none for now because we don't have that hint developed yet. And then we also had warm, cold. So those were the two hints that we had, and they're both none for right now. But this is how our hint system is going to work. And what we're ultimately going to do is we'll put the class of the hint into here. Okay, that's our pattern for using hints, and it will become more clear once we actually get to that. But for now, this will just print out the keys, and let's just run this really quick so I can show you what's happening here. So if I press H, we're printing out, it says choose a hint from the following hints, and then it says dict keys, and then it gives us the list of keys, and that's because we're calling hints.keys. So if we did something, I think this is called list comprehension. So if we do create a list, and then we say I in self.hints.keys, and we run the same program, now we no longer have the dict keys statement, and I think it just looks a little bit cleaner, so we'll do this instead. And the way that this list comprehension works is that you can have some iterable item, like it could be a list, so you have L equals 1, 2, 3, 4, and now you want to create a separate list, so you could say like L2 is equal to, and now you create a second list, but you're going to iterate through one list, right? So you say like I plus 1 for I in L. So this is saying like, it's kind of like a for loop. For I in L, I plus 1. But you just kind of write it a little bit differently. So now if we, L2 should be 2, 3, 4, 5. 2, 3, 4, 5. Yeah, so that's how list comprehension works. And whenever you can, you should use list comprehension over like a traditional for loop, because list comprehension is faster. All right, so now we have our way of taking in the hint from the user. We haven't developed any hints yet, so let's just print out the hint that is being used. And we kind of already know that this works, but just to actually do it, let's try this out. All right, so warm, cold, and then it prints out warm, cold. Now we can use this hint to actually get the hint that we want to use, right? So we can say, I guess we're not going to call this hint here. We'll call this, we'll just say, or no, we'll say name. And then we'll say hint is equal to self dot, actually this isn't even hint, this is hint class. Self dot, what am I doing here? Self dot hints name, and now here's where we create the hint. Hint is going to equal hint class, and we have to instantiate the class. And when we instantiate our hint class, we need to pass in the game. Okay, this is how our pattern is working. Okay, let's flush out this pattern and get it fully working. So let's go over to our hints file, and let's actually create our classes for the bisection hint, and this will have a def init method, and we'll pass in a game. We're not going to use any inheritance here, because it's just going to overcomplicate things. It's not necessary to use inheritance. Instead, we use duck typing. Okay, so all of the hints need to look like a hint, which just means that they need this init method where you're passing in a game, and it also needs a apply method. And I don't remember. Oh, you don't need to pass. You don't need to pass anything into the apply method. Actually, you shouldn't pass anything into the apply method. And then here is where we put the logic for our hint. This is how our hint actually works, and it has access to the game, so it can get these attributes of the game, like the number of guesses, the range, the points. It can get all those things for applying the hint. So that's how this one's going to look. And now we also have our warm, cold hint, and we have definitely, and we have game. Then we'll do self dot game equals game, and def apply pass. All right, so now we have the pattern complete. This is how it's going to work. So that means we need to run hint dot apply, and we'll return. We'll have a couple other cases where down here we'll say if name is equal to help, we're going to want to do something. Okay, we need to get the help statements from each of the hints, which reminds me, we need to put the help statements in here, and I'll show you how I decided to do that. So in here we'll say if name equals help, we'll do something. And then I also came up with this elif name is equal to Q, then we're going to go back, so we'll just return. And I should probably put that in here that you can actually do that, but I just did that for my own purposes. I found that useful. And then we'll say else. We're gonna run this here. All right, so if it is if it's help, then we'll ultimately just go right back through through the next loop of the while loop. The apply method from each hint needs to return a message to the user. This is like the hint. This is the message of the hint, and it also needs to return the cost of using that hint. So that's another restriction for our apply method on each of our hints. It needs to return a message and a cost. And then we can have another print statement, and I'll just copy and paste this print statement so that way you don't need to watch me type out this string. So we'll just say hint is, and then our message, cost, and the cost, and we'll also give the user the current score just so they know like where they stand in the universe of our game. Okay, so after we return from our hint, we're gonna go back to this loop, and so it's here, and we'll just continue. So then we go through the while loop again, and that's how the logic works. I guess we can just quickly do at least part of this help statement. So if we go into hints, here's how I did the help statement. So I just did it as a attribute of the class itself. Okay, so statement, and then we can just put the help statement in here. So I'm going to copy and paste it from my other code. That way we don't need to be typing out strings here. For the warm cold one, I did things slightly different. Since the cost is hard coded, I hard coded the cost up here, and then I just used that within the string. So, because that way, if you ever want to change the cost, you just change it here, and it will update here, and it also updates in the apply method too when we actually write that out. If they're gonna call help, then I came up with a separate method for get the hint helps. Get hints help. Get hints help. I guess that works. So I did a separate method for this. That way, again, I don't need to shove a bunch of logic into this if statement. So let's come down here, and we'll do def get hints help, and now we just need to iterate. We have the name and the class for self dot hints dot items, and this is actually one of the main reasons why what is going on here? For name class in, oh, yeah, okay. All right, so now because we created these attributes as class attributes, we don't need to instantiate the class. We can just call help statement. All right, so, and also we want print. So print help statement. I think I made it look a little bit nicer in my code that I wrote before, so I'm just gonna grab that. Hint name, oh, and I just did KV before, but I'll fix this. So name and class. All right, so we're gonna print the hint name, which is name, and also the help statement, which is just class dot help statement, and then we'll have a line between each one. So we'll just have an empty print statement, and that's it. That's all that needs to happen here. So then we can return. This is complete now. It looks complete. So the get user hint is complete. Next, we can move on to apply guess. The hints aren't complete though. We need to complete the hints. We'll do that. Let's first do apply guess. So in order to apply a guess, we first need to check if the guess is equal to self dot answer. And if it is, then we want to set correct equal to true. Else correct is equal to false. So that's the first thing that we need to do. All right, and the next thing that we want to do is we will check if guess if guess not in self dot guesses. I think maybe this is how we write this. If not guess in self dot guesses. And now we want to say cost is equal to and the way that I determine the cost is with a simple little function here. So I just say self dot num range, and it's the second value in the number range, divided by I guess we could do integer division here. So having these double forward slashes, we'll just get the integer. No, we'll do floats, and we can do self dot max points. Let's say we want to switch up the range to 0 and 10. Well, each guess should cost 10 points, not just one. And this is going to allow us to do that. So this is like the cost per guess, I suppose. But we'll just call it cost. And then we can come down here and we can do self dot apply guess. No, sorry. Apply cost. And then we'll pass in the cost. And the apply cost method that we're going to create is extremely simple, and it probably could just be in the apply guess, but it makes sense to have it as its own separate method, because then we can use it in the hints. So we want apply cost, and we're going to pass in the cost. And the way that the cost is going to work is going to be self dot points minus equals cost, and then we can return self dot points. Otherwise, if guess is not in self dot guesses, or if it is in self dot guesses, then we won't charge anything. So we'll just say cost is equal to 0. We don't need to apply the cost because cost is equal to 0. And then down here we will return the we'll return correct. So whether or not it is correct or not, and we'll also return the cost. In our run method now, we are going to have correct, and we're going to have cost, and we can use this to determine the logic of our game. Should we continue, or should we end the game? In our run method, underneath this this apply guess, we're going to need another if block. And this if block is just saying, if correct, then we want to print out, congratulations, you won. Your final score was self.points. And then we return. And otherwise we say, sorry, that guess was incorrect. Your current score is self.points. So it's been a little while since we ran our code. Let's try running our code again and make sure that everything is working. So if we try 75, sorry, that guess was incorrect, and our score has decremented 74, 73. All right, so the game is working properly at this point in time. And the apply, we're done with apply. Oh, we're not completely done with apply guess actually, because notice how we are checking if not guess is in self.guesses, but we actually haven't done anything to keep track of the guesses. So here's where we need to change up this up here. So I want to actually store the guesses as a set. Okay, this will make indexing into it faster, so we can do our lookups, like is this number in this data structure a set? It'll be faster. And the other thing is that we only want like one guess stored in our data structure. We don't need multiples of guesses. We just need, if a user guesses 3 multiple times, there's only going to be 1 3 in our data structure. So this can be enforced by using a set data structure. So let's go down and just modify some things here. This will still work the same way. We can still use this for a set, but now when we add a guess, we can't just do we can't use append. We have to do self.guesses.add, and then we can add the element. We'll add guess. So that's it for that actually. Now we're done with that, and it looks like we're completely done with the apply guess method. Okay, we're coming down the home stretch here. This next and final part that we're gonna do is building out the logic for our hints. So we need to develop our hint classes, the apply methods for each of them. So let's start out with the bisection hint. The way that our bisection hint is going to work is we are first going to come up with a list of values that we could possibly guess. Okay, so it's kind of like the opposite of the guesses. We want a list of values of all of the possible guesses that we could guess, and then we want to divide that in half. We want to be able to split that in half. And there are a number of ways that you might be able to think about doing this, but it becomes more complicated when you start factoring in the guesses that have already occurred. So the simplest way that I know to do this is we'll do some list comprehension here. So we'll say for I in range, and then we want self.game.num range, and we want the second value, so the largest value. So what this is going to do is this range function is going to create an iterable of that is of length whatever value is passed in. In this case, it's the number range, the highest value in our number range. So if it's 100, then we are going to iterate 0 through 100. And maybe actually, now that I'm thinking about this, we might want to do +1. So maybe we should do like 1 comma range +1, and we can just make sure that this is working properly. So let's come down here into our Python console, and let's see what this values list is going to look like. Values equals for I in range 1 comma 101. Alright, so now values is, alright, so this is what we want. So it ends at 100, it starts at 1, because we're talking about the guesses here. We're not talking about the index of the guesses. We're talking about the actual guesses. So we want the user to be able to guess 1 to 100. And I think even in the game rules it said like 0 to 100. Let's run our program and just see what it says again. Between 0 and 100. It says between, right? So we'll do 1 to 99. Those are the possible guesses. 1 to 99. That makes the most sense to me. So I just took away the +1 here. I'm taking away the +1. There's one other thing that we want to add to this. So we can have a conditional statement in our list comprehension. So we're going to say if I not in self.game.guesses, because we want to exclude the values that have already been guessed. That's how this is going to work. With this, we can come up with a list of values. Okay, now we want the index for the halfway point. And the way that we can get that is we can say halfway IDX for index. Oh, I forgot my F here. Halfway index is equal to the length of values. Then we want integer division. So we want an integer returned, and we'll do divided by 2. So now we have the index for the halfway, and now we can get the value for the halfway, and we can say whether or not it's greater or less than. So we can say halfway, I forgot the F again. Halfway is equal to values, and now we want to index into that, and we'll use the halfway index. Okay, so now we have the halfway value, and we can say if guess is less than the halfway value, then we want to tell the user like your value is greater than or less than the halfway value. And if it's we need the halfway value, we need the symbol, is it greater than or less than, and then that's going to be the message that we return. It's going to be telling the user, is the answer greater than or less than the halfway value. And since we also need to account for if it is equal to the halfway value, I decided to just say greater than or equal to the halfway value or less than the halfway value. So we'll say if self.game.answer is less than the halfway, then our symbol will be less than. And elif self dot game dot answer is greater than or equal to halfway, then our symbol is greater than or equal to. And now we can put together the hint that we're going to give the user. So I'll grab this because it's another string here. So we have hint. The correct answer is it will be greater than or equal to or less than halfway, and we'll give them the value. So this is what we are going to return. We also need to figure out the cost of this though, right? So we're gonna have cost equals self dot game dot apply guess. All right, so the way that this part of things could work, like maybe we could figure out the cost of this hint within this apply method, and then apply the cost and apply each of the individual guesses. But what I decided to do was I came up with a new method in our game, which is apply guesses, and its main purpose is to be used within hints. All right, so let's do def dot apply guesses, and then here you can pass in a certain number of guesses, and then we'll just say like for guess in guesses self dot apply guess, and we'll pass in the guess. Okay, so now in our hint we can do game dot apply guesses, and we have to be able to pass in the guesses. So in here we need to get our guesses. So guesses are going to be equal to values, and if it's less than, then we want up to the halfway index, and if it's greater than or equal to, then we want our guesses to be equal to values, and we want halfway index to the end. Oh, and actually, now that I'm thinking about this, I just mixed up the order of these. So this one should be on the top here, and this one is down here on the bottom. So let's just go through this again. So if the answer is greater than or equal to halfway, we'll just use 50 as an example, then, or like 100, there are 100 possible solutions. So if it's like 75, then it's greater than or equal to 50. So that means we're dropping 1 through 49. So the guesses that we've taken are 0 to 49. And if it's less than the halfway point, then we're dropping 50 to 99. Okay, so that's how that's gonna work. The logic for our hint is looking good. So we have the cost figured out here. The pattern for our hint is that we are returning the cost, I believe. I don't remember, I have to look this up. So we're getting the user hint, we're returning the message and the cost. So the hint and the cost. So we can come down here and we'll return the hint and the cost. Oh yeah, so in our apply guesses, when we're calling the apply guess, we don't want to add each of our guesses to the last guess. Okay, this is a little confusing, but the previous guess, sorry. You know, we're storing the previous guess in, which we didn't actually do. Oh yeah, I didn't do that on purpose actually. In here, we need one more if block in our apply guess. What we're gonna do is we'll create a parameter called prev guess, and it's gonna be set to true. And we'll say if prev guess, then we'll say self dot prev guess equals guess. So we'll store the guess that is being made as the previous guess, so that way we can access it within like the warm cold hint, for example. But in our apply guesses, when we do this, we don't want to store each of these guesses as the previous guess. So we're going to call false on the apply guess, and that way we're not storing them as the previous guess, because it's not a user guess, it's a guess from the hint system. So that's what I wanted to add there. And now it looks like we're completely done with that, and it looks like this should work. So we can just zoom out and see our bisection hint. Let's give it a go, see if it's working. All right, so guess a number between 0 and 100, or type H for hint, H. Then we'll type in bisection, and it's not working. None type object is not callable because we did not update our game. And remember, this is a requirement here, so we need to from number guessing game dot hints import. We'll just import all. Now we want bisection hint, and we just have the class. Don't instantiate it, it's just the class. Okay, so now we oh, we can also, while we're here, we can also fix the warm cold hint. Now let's run our code. Do H bisection. All right, so the correct answer is less than 50. Current score is 50. That looks good. All right, now we need one more hint, and then we are done with this program. Let's do the warm cold hint. So let's go over to our hints, and warm cold, we need to apply our warm cold hint. For this one, we need the previous guess. So we'll just do no, we don't need, maybe we don't even need a variable for it. Oh yeah, so the first thing that we need to do is just check if there is a previous guess. So if not self dot game dot prev guess. Just remember we're starting out with the previous guess as none. All right, so if there is not a previous guess, then we're gonna print something like, hey, this doesn't work unless you have a previous guess. So for that case, remember that our apply hints are going to return a message and a cost. So we'll just create a message that says you must take at least one guess before using this hint, and we'll return the message and none because the cost is none. Yeah, so that's what we'll do for that. And then outside here, we're not going to do an else statement. We're just going to return from here. So outside here, we're just going to have the code for the normal situation. All right, so the way that I did this logic here is if self dot answer, oh no, sorry, if self dot game dot answer times 1.15. Okay, so that's 15%. So if it's, what we're ultimately doing is we're saying like if your last guess was less than the 1.15 of the answer, or greater than the answer times 0.085. And if it meets that condition, then we want the temperature to be warm. So if self.game.answer times 1.15 is less than, no, greater than self dot prev answer. Oh, and I guess we can do greater than or equal to. I keep doing self.prev answer, but self.game.prev answer. And now we also want, and I did plus here. So this is equal to, and then this one should be less than or equal to self.game.answer multiplied by 0.85. All right, so if those conditions are true, then the temperature is equal to warm. And we're just gonna pop in an else statement here. Else the temperature is cold. And now we need a message for ourselves. So we'll do message your last guess of self.game dot last guess. I called it last guess in my other code. We'll say previous guess was temp. So was warm, was cold, whatever. And now we want to use the game apply cost method. So self.game.apply cost. And remember that we stored the cost as an attribute of the class, which becomes an attribute of the object after you instantiate it. So self.cost. And this way, when we change the cost, we don't need, like before, I didn't do it this way, and I was trying out different costs, and I would have to change it here, and then I'd have to go remember to change it up here. So I just decided, all right, create a single variable here, change the cost here, it will change it here, it will change it here, and yeah, we're good to go. So what we want to return from here is self dot, no self dot. We want to turn the message and self dot cost. All right. So we have our warm cold hint. Let's give it a go. Let's try 85. All right. Let's do a hint. Let's do warm cold. Damn, didn't work. Prev answer is not a thing. Oh, previous guess. That's why. Okay, so prev answer is not a thing. We want the previous guess. H warm cold. Hint, your last guess of 85 was cold. All right, let's try 15. Let's use the hint. All right, so 15 is warm. See, now I'm thinking about something here so I'm thinking that we should change this warm cold hint from, all right, I think we should do this instead. So plus self dot game dot num range 1. All right, I think this makes more sense here. So I'm just updating this here. So it's 15% of the overall number range. I think that makes more sense for this warm cold hint because it will be like plus or minus 15. And I was trying to get that before, but I was just doing it wrong. This now should work. But yeah, this is our program. It looks like we are done with it. There are probably more things that we could do with this program, but I don't want to overkill it. I think that this is plenty. I guess we can add our starting game print statement. All right, that's it for this video here today. We built a number guessing game. This is project 2, and just for those of you who made it this far to the end, this is the blog post that I'm following along with. There are 42 projects. I'm not going to do all of them because some of them I don't know, some of them don't really make sense. Some of them can be added together. So for example, the next one is this text-based adventure game. I'm not going to do that because I don't understand it. I don't understand what they want exactly, and it doesn't really seem that interesting. So instead, what we're going to do next is a dice rolling simulator. I expect this to be much simpler than the one that we just did. And because of that, I'm going to use it as an opportunity to introduce using the terminal, basically, like having a command line application. So we'll build out a command line interface for this dice rolling simulator, and that's how we're gonna build this project. And then after that, we'll do Hangman. We'll do the contact book. This email slicer we won't do. We'll do this in the contact book because the email slicer just doesn't make any sense. It's really short. So we'll do the email slicer in the contact book. We'll do the binary search algorithm. It's similar to the bisection thing that we did in this number guessing project. We'll do the desktop notifier app, Python story generator. I'm not going to do that because it's very similar to the Mad Libs one. YouTube video downloader. We're definitely going to do something with this. I'm not exactly sure what we're going to do with this, but we'll do something with the YouTube video downloader. Website blocker. That seems interesting. I'll give that a shot. Yeah, these other ones I haven't really looked at that much, but then when we get into the intermediate ones, I might start moving away from doing like just basic Python applications and might start doing more like web-based stuff. So for the calculator, I might like bring in a a web framework of some kind and build out like some HTML for the user interface, as opposed to doing like to Kinter as they recommend here. I might just start doing web stuff. Countdown clock timer, sure, we can do that. Random password generator sounds cool. Random Wikipedia article, okay, that seems cool, we can do that. A Reddit bot, I have no idea, we can give it a shot. So yeah, Python command line application. You can create your program which can help you send emails to other people. The program will ask your credentials and content of the email. Okay, we'll do some type of command line application. So yeah, there are a bunch of different projects that we can do. And then when we get to the advanced ones, we have like speed typing test. That will be cool. Content aggregator, bulk file name image resize application. I've done some code with this, so that one will be cool. Python file explorer, sure, we can do that. Plagiarism checker, that will be interesting. Web crawler, definitely looking forward to this one. A music player, all of these ones will probably be web-based applications too, so not just in Python, but we'll use some JavaScript too. But yeah, all of these look pretty cool. I'll do most of these projects, might tweak them a little bit, make them more of my own. But yeah, so that's what I'm going to be doing, focusing here on this channel. I also have other videos where I just talk about random things, but these are the projects that we're going to be doing for a while. Either during these projects or after these projects, I'm also going to be starting a new thing, which is going to be an AI course. We're going to be doing a full AI course. So stick around for that. Be sure to subscribe, like the video. I'll see you next time. Thanks for tuning in.